Hello, grade 11s. We're on our fifth day of sequences and series, second last. We're looking at the series part today and tomorrow. So apparently, Carl Friedrich Gauss, who you've heard of the Gauss math contest, 200 years ago, his teacher was trying to make them put in some time, and he asked the students to add the numbers from 1 to 100. So everybody sat very busily trying to figure this out, and apparently Carl was moments, and he had it figured out. And his method is going to help us with arithmetic series today. He had an interesting way of looking at it. He knew that adding from 1 to 100 would be adding 1 and 2 and 3 and 4 and then a whole bunch more, and then 96, 97, and so on to be finished. So he thought that if he added the 1 and the 100 and the 2 and the 99 and so on, he could establish a pattern. 100 plus 1 is 101. 2 and 99 is 101. 3 and 98 is 101, and so on. So he had a series of 101s, and he had to figure out how many of them he had. So the last pair that he would add would be the 50 and 51, which is your 101. This pair was the 1 and the 100. So altogether, he realized that he had 50 pairs of 101s. And so his sum of 1 to 100 was 50 times 101, which is 50-50. So he was adding the smallest and the largest, and he was doing 50 different pairs, not 150. You can keep that in mind as we develop arithmetic series. So Stephen gets a construction job that pays $1,000 a month plus an increase of $15 a pay each month for a year. What is his salary in the 12th month? Well, we can certainly write out our arithmetic sequence because he is adding the same thing each time. So his first month was 1,000. His next month was 1,015, 1,030, and so on for 12 months. What would his salary be in the 12th month? Well, instead of writing them out, we can use our notation that we had last time. Our 12th term would come from this, our initial value, or our first term, and n minus 1 of the common difference. So our 12th term would be 1,000 plus 11 15s. So the 12th term would be 1165. What is his total salary for the year? Okay, 1,000 plus 1,015 plus 1,030, 1,045, 1,060. How many have we got? 5. 1,075, 90, 1,105, 1,120, 1,135. Poor Stephen, we need to come up with a better method. Plus 1,165, and we know that's the 12th month. So those are his different monthly salaries. The total is $12,990. This sum of an arithmetic sequence is an example of an arithmetic series. An arithmetic sequence would be something like 2, 4, 6, and so on, where the arithmetic series would be 2 plus 4 plus 6 plus, and so on. 12, 9, 6, 3 is arithmetic. It has the same common difference. In series form, it would be 12 plus 9 plus 6 plus 3, and so on. The general A general arithmetic series with n terms is a plus d, so we've added a common difference, plus a plus 2d, plus, and so on, plus a plus n minus 1d for the nth term. We can put that together in a formula. And we are using that Gauss thing where he did the 50 sums. It was right in the middle. The sum of n terms. Sum of n terms is the halfway point, so 50 sums, not 100 sums, n over 2 times a plus the nth term. So you can take that like Gauss did. He took the first term, which was 1, and the nth term, which was 100, and he did 50 of those. Another way to write it, which is the way I always use it, is the sum of n terms is n over 2, 2a plus n minus 1d. This comes from the fact that the nth term is a plus n minus 1d. And if you put that all together, you have the form that I have it in black. And it's just easier to plug the things in. N is the number of terms. A is the first term. Tn, if you use that version, is the last term. And D is the common difference. Let's do a few. Find the sum of the series. So we have a series, 5 plus 8 plus 11 plus all the way to 6. So we want to find the sum of 6 of them. So this should be a T6 actually, T10, T20. Let's find the sum of 6 of them. My formula would be the sum of 6 is, just going to write in general form first, n over 2, 2a plus n minus 1d. There is my general, so sum of 6 of them would be 6 over 2. 2 times my initial value is 5, plus n minus 1 is 5 of the common difference, which is 3. 3 times 10 plus 15, which is a total of 75. So the sum of 6 terms, and we don't even know the last 3 terms, but it's 75. Let's find the sum of 10 terms. I have the formula above in red. Let's just make him an n. There we are. The sum of 10 terms for this one would be 10 over 2, 2 times the first term, plus 9 common differences, and the common difference is 2. It wouldn't hurt for you to show not all of them are going to be this simple, that you have found your common difference. 5 times 2 plus 18, 20 times 5 is 100. Sum of the first 10 terms is 100. I want the sum of 20 terms for this series. 20 over 2 times 2 times a, 2 times the first term, plus n minus 1 is 19, common difference. the common difference, it's going down by 5 each time. Negative 5. So we have 10 times. 20, 5 times 19. It's 95. 10 times negative 75 minus 750 is the sum of the first 20 terms. Find the sum of 20 terms if the first term is 53 and the second term is 37. So we know this series looks like this, and we want to find the sum of 20 terms. So our A is 53. Our common difference is 37 take away 53, which is negative 16. The only reason from two terms that we can assume it's an arithmetic series is that I'm telling you so for these two questions. Otherwise, you wouldn't know if it's geometric or arithmetic. But these two are arithmetic. So we have our A, we have our D. We can find our sum of 20 terms. It's n over 2, 2a plus n minus 1b. It is 20 over 2, 2 times 53, plus 19 of the common difference. Two times 53 is 106. 19 times negative 16 is negative 304. And when all the smoke clears, negative 1,980. All right, a little more challenging one. Find the sum of 15 terms of the arithmetic series when we know that the seventh term is 53 and the 11th term is 97. And we want the sum of 15 terms. Yikes. We need to find our A and our D. We know that we want the sum of 15, so n is not a problem. Well, what do I know? I know if it's arithmetic. And my seventh term is 53. I know that to get the seventh term, I have A plus 6, common difference, n minus 1. I also know for my 11th term, which is equal to 97, I can generate that by initial value plus 10 of the common difference. So if I use these two equations, I can find my A and my D. So I'm going to use those two equations to solve for A and D. I'm going to do equation 2 take away equation 1. So I'm basically thinking about substitution and elimination from grade 10. 97 take away 53 is 44. A take away A is gone. 10D take away 60 is 4D. And so I have found out that my common difference is 11. Once I know that, I can substitute D equals 11 into number 1. I had to choose one, it doesn't matter. 53 equals A plus 6 times 11. If I were to subtract 66 from both sides, I have minus 13 for my A value. I'm going to check quickly to make sure I did that correctly. Check number 2. 97 for the left side. For the right side, I have A plus 10D minus 13, apparently, 10 times 11. Minus 13 plus 110 is in fact 97. So I have found my A and my D values. We want to know the sum of 15 terms. n over 2 times 2a plus n minus 1d. 15 over 2. 2 times, there it is, minus 13 plus 14 of the common difference. Common difference is 11. 7.5 times minus 26 plus, I apologize, the recording paused on me and I'm not sure where, so I'm going back to the beginning of this problem and I'll redo this and I'll see at the end how it turned out for me. Okay, from the beginning. The 10th term of an arithmetic series is 34 and the sum of the first 20 terms is 710. We want to determine the 25th term. So to find the 25th term, I need the first term, haven't got it, and I need 24 of the common difference. So that's my goal. What do I know? I know that the 10th term is 34. I also know how to generate the 10th term. It's the first term plus 9 of the common difference. Secondly, I know that the sum of the first 20 terms, so I know that, is 710. I also know to generate the sum of the first 20 terms, I would do n over 2 2a plus 19 of the common difference. Oh, I know n, so I can put 20 there. So just like the last one, but in slightly uglier form, I have two equations and two unknowns that can help me find a and d that will allow me to find the 25th term. Okay, equation number 1. 34 equals a plus 9d. The second one, I'm just going to tidy up S20. This fraction is really a 10. And if I did distributive law, just to tidy it up and make it look better, I would have 710 equals 10 times 2a is 20a. 10 times 19d is 190d. So two equations and two unknowns. We're going to solve for a and d. There's lots of ways to do this. I would, because I like elimination better, but it doesn't matter, I would leave the second one the way that it is, and I would multiply the first one by 20. So times 20, 680 equals 20a plus 180d. From there, to get rid of, and the reason I did that, let's multiply, show what we did, was to have the coefficient the same in front of a so that I can subtract now and get rid of the a so I can solve for d and have it by itself. So 680 subtract 710, negative 30. My a's disappear. Subtracting the d's, 180 subtract 190 is negative 10 of them. Divide by negative 10, d is 3. To find my a value, I'm going to substitute d equals 3 into number 1. 35, and I'm going back to the original number 1. So I am lazy, and I look for the easy cut. Okay, a plus 27 equals 34. Subtracting 27 from both sides, I get 7. My a value is 7. Oops. Back to the top. I wanted the 25th term. The 25th term is 7 and 24 of the common difference, which was 3. So my 25th term will be 7 plus 72, 79.